Yes, so can you guys hear my voice?
Yes,
If
sir.
it's
Yes, sir.
okay, that's good. Can you also see my slides?
Yes, sir.
Yes, sir.
Oh, that's good. So welcome to the second half of the semester. The first half was a preparation. In that preparation, we studied concepts in language and meaning. We also studied statements that are not logical. And we learned to identify passages that are argumentative or not. Now it's time to study arguments. Now on to the different forms of reasoning. Arguments are also called reasoning or syllogisms, so the three terms are used interchangeably. Now we have two major categories of reasoning, deductive and inductive. We also have causal reasoning, but it's a form of inductive reasoning. Now on to deductive reasoning. Deductive reasoning is also called deductive argument, deductive syllogism. Now, it is reasoning in which the relationship between the premises and the conclusion is a logical relationship. As a result of this, it's reasoning that permits only one conclusion. Now, it's just like a mathematical operation. When you add 2 and 2, it permits only one conclusion, and that is 4. So that's the nature of deductive reasoning. Now, example. All men are mortal. Kofi is a man, therefore Kofi is mortal. Now, you cannot change or modify the conclusion. For instance, you can't say Kofi is immortal or a fire cabinet is mortal. Now, before we go into deductive reasoning, let us look at two parts of a sentence that are analogous to the subject and the predicate. Now, when we are discussing arguments, we refer to two parts of the sentence, the reference class, which is just like the subject, and the attribute class, which is just like the predicate. Example, all men are mortal. All men will be the reference class, and are mortal will be the attribute class. Now, the reference class is that to which the sentence refers. That to which the reference refers is the reference class. Whilst the attribute class is that part of the sentence that is attributing something to or saying something about the reference class. Now, there are two kinds of reference classes. We have the finite and infinite reference classes. The infinite reference class refers to all members or no members of a class, either 100% or 0%. Example, all men, no man, any man. Now, these are classes containing uncountable items. All men cannot be counted, same as no man or any man. But the finite reference class refers to countable and particular members of a class, anything between 0% and 100%. Example, some men, 80% of men, 5 men, 2 men, all the men, few men, all of the men, and so on. Now, all the men is countable, but all men is not countable. All men refer to men both born and unborn, but all the men refer to men in a particular context or place. All the men in this class, all the men in this school, all the men in this country, all the men in this world. Now, they can be counted. So these are the two kinds of classes, reference classes, finite and infinite. Then you have the universal and particular statements. Statements containing infinite reference class are called universal statements, whilst those containing finite reference classes are called particular statements. Example of universal statements, all men are mortal. Example of particular statements, some men drink alcohol. So the universal statements are statements containing the infinite reference class. The particular statements, those containing the finite reference class, the class of countable items. Now let's do a little exercise. Which statements are universal and which are particular? This table is three-legged. Is it universal or particular? So any of you can answer that by raising your hand or muting your microphone.
Particular.
This table is three-legged. Yeah, so go ahead.
Say particular.
Particular. Tables can be sat on. Tables can be sat on.
Universal.
Universal. James and Mary passed the examination.
Particular.
All visitors should be treated with respect.
Universal.
Okay, that's fine. Now, there's the thing about validity. Now, a valid argument is a deductive argument that is correct. Any deductive argument that is correct, we call it a valid argument. Now, it doesn't apply outside deductive arguments. So, to read here, an argument is valid if the premises make the conclusion necessary and the conclusion follows with certainty. All valid arguments are deductive arguments. All valid arguments are deductive arguments. So inductive arguments are strictly not valid. And so an inductive or a deductive argument is a purely mathematical argument. A deductive argument is a purely mathematical argument. The relationship between the premises and the conclusion is logical. So you can refer back to the example of deductive argument that we just saw. Now let's compare it to an inductive argument. Now this is an example of an inductive argument. 95% of men are honest. Peter is a man, therefore Peter is honest. In this case, more than one conclusion is possible. Peter could be among the 95% of men that are honest, and Peter could also be among the 5% that are dishonest. So that's why more than one conclusion is possible. Possible conclusion 1, Peter is honest. Possible conclusion 2, Peter is not honest. Any argument that presents more than one possible conclusion is an inductive argument. If an argument presents only one possible conclusion, then it's a deductive argument. So that's one of the key differences between deductive and inductive. Inductive argument is one possible conclusion. Inductive arguments will give you more than one possible conclusion. Now let's look at the hidden conditional if and then. If and then. Statements containing if and then are called conditional statements. If I get paid, then I'll pay my debts. If America gives me visa, then I'll travel to America. If this, then that. If that, then this. So such statements are called conditional statements. Now there are two ways of looking at arguments. You can look at them in categorical or conditional ways. Now all arguments have hidden conditionals. Now let's look at this conditional statement. All men are mortal. It's a categorical statement. To convert it to a conditional statement, we'll say if something is a man, then it is mortal. All men are mortal. If something is a man, then it is mortal. That's a conditional version. Now, let's change the categorical statement of premise 1 of our deductive argument to a conditional statement. Instead of saying all men are mortal, we'll say premise one, if something is a man, then it is mortal. Premise two, Peter is a man. Conclusion, Peter is mortal. Now, this way of looking at the argument will show you how the argument flows and how valid the argument is. If something is a man, then it is mortal. Peter is a man. Therefore, Peter is mortal. So we normally convert the major premise to a conditional when we want to analyze the strength of an argument. Now let's also replace words with symbols. Now this is a categorical version. All men are mortal. We'll say all A's are B's. All A's are B's. Men are A's, mortal are B's. All A's are B's. Peter is a man. Will be X is an A. Now men, since men is A, Peter is a man will be X is an A. Peter is mortal will be X is a B. So with symbols we would have all A's are B's, X is an A, therefore X is a B. Now this is also something we do when we deal with deductive arguments. Now let's look at the conditional version. If something is a man, then it is mortal. Peter is a man, therefore Peter is mortal. If A, then B. If A, then B. X is an A, therefore X is a B. Or you can remove the X. If A, then B. A, therefore B. Now, antecedents and consequence. This is the major way of working with a deductive argument. We work with antecedents and consequence. Now, to understand antecedents and consequence, now remember the reference class and the attribute class. The reference class is like the subject, the attribute class is like the predicate. If we restate any categorical proposition as a conditional statement, if we restate any categorical proposition as a conditional statement, the reference class becomes the antecedent and the attribute class becomes the consequent. The reference class becomes the antecedent, the attribute class becomes the consequent. Example, all A are B, or if A then B. All A are B is categorical. If A then B is conditional. The reference class, in this case A, is the antecedent, and the attribute class, in this case B, is the consequent. So A is the antecedent and B is the consequent. So any statement referring to A will be either affirming or denying the antecedent, and any statement referring to B will be either affirming or denying the consequent. Now, since A is the antecedent and B is the consequent, if I say X is an A, if I say X is an A, I am making a statement that affirms the antecedent. If I say X is not an A, I'm making a statement that is denying the antecedent. If I say X is a B, I'm making a statement that is affirming the consequent. And if I say X is not a B, I'm making a statement that is denying the consequent. Let's look at examples. X is an A, affirms the antecedent. X is not an A, denies the antecedent. X is a B, affirms the consequent. X is not a B, denies the consequent. Okay. Okay, I had to take a minute. So X is an A, affirms the antecedent. X is not an A, denies the antecedent. X is a B, affirms the consequent. X is not a B, denies the consequent. Now let's look at an example of affirming the antecedent. This is an argument. All A's are B's. X is an A, therefore X is a B. All A's are B's. X is an A, therefore X is a B. Now X is an A affirms the antecedent. It affirms the antecedent. Because of that, we will say that the whole argument affirms the antecedent. It is an argument that affirms the antecedent. Or we will say that the argument affirms the antecedent in order to reach its conclusion. It is an argument that affirms the antecedent in order to reach its conclusion. Now, denying the antecedent. All A's are B's. X is not an A. That denies the antecedent. Therefore, X is not a B. Now, we will say that this is an argument that denies the antecedent in order to reach its conclusion. Affirming the consequent. All A's are B's. X is a B. That's a statement that affirms the consequent. For that reason, we'll say that this is an argument that affirms the consequent in order to reach its conclusion. Denying the consequent. All A's are B's. X is not a B. That denies the consequent. Therefore, X is not an A. So we'll say that this is an argument that denies the consequent in order to reach its conclusion. Now, so these are the four possible ways an argument can go. It is either an argument affirms the antecedent, or it denies the antecedent, or an argument affirms the consequent, or it denies the consequent. It can go any of four ways. Now, out of these four ways, only two ways will give you a valid conclusion. The other two ways will land you in a fallacy. The other two ways are invalid arguments. Now, what are the two ways that are valid? Let's see about that. Now, this is a rule for deductive reasoning. We only affirm the antecedent and deny the consequent in order to reach a valid conclusion. Any other operation will make the argument lose its validity. So the only valid argument is to affirm the antecedent or deny the consequent. If we deny the antecedent, it will not be valid. It will be an invalid argument. And if we affirm the consequent, it will be an invalid argument. So the only valid arguments are to affirm the antecedent or deny the consequent. So let us see the reason why. Example, all A's are B's. X is an A, which affirms the antecedent. Therefore, X is a B. Now, the rule tells us that this is a valid argument because it affirms the antecedent. Then the second example, all A's are B's. X is not an A, which denies the antecedent. Therefore, X is not a B. Now, the rule is telling us that this is not a valid argument. Now, let's see the reason why by putting the symbols in words. All Ghanaians are Africans. Peter is a Ghanaian, which affirms the antecedent. Therefore, Peter is an African. Now, the rule is telling us that this is a valid argument. Why is it a valid argument? You can understand why it's a valid argument by looking at the argument again. All Ghanaians are Africans, which is true. Every Ghanaian is an African. Now, we are told that Peter is a Ghanaian. Now, if Peter is a Ghanaian, If Peter is a Ghanaian and all Ghanaians are Africans, then Peter is an African automatically. That's why the argument is valid. If all Ghanaians are Africans and Peter is a Ghanaian, then Peter is an African. There is no way that Peter cannot be an African. Now, look at the second example. All Ghanaians are Africans. Peter is not a Ghanaian, which denies the antecedent. Therefore, Peter is not an African. Now, we are told that this is not a valid argument. Why is it not valid? We'll understand why it is not valid by looking at the argument again. Now, all Ghanaians are Africans. That's true. Now, if Peter is not a Ghanaian, is that enough reason to say he's not an African? Can you prove that Peter is not an African by simply proving that he's not a Ghanaian? Or is proving that Peter is not a Ghanaian enough to show that he's not an African? So it is not enough. Because in order to show that Peter is not an African, you cannot just prove that he's not a Ghanaian. You also have to prove that he's not a national of all the African countries. You have to show that Peter is not a Togolese or a Nigerian or an Ivorian or a Cameroonian or any of the African nationalities. You have to show that he doesn't belong to any African country for us to reach the conclusion that Peter is not an African. So saying that Peter is not a Ghanaian is not enough reason. It's not a valid argument to conclude that he's not an African. That's why we say that the argument is not valid. And that's why we say that denying the antecedent cannot give you a valid conclusion. Denying the antecedent is not enough reason for the conclusion. So the argument is not valid. The first one is valid, the second one is not valid. If you show that Peter is a Ghanaian, then you have automatically shown that he's an African. If you show that Peter is not a Ghanaian, you have not automatically shown that he's not an African. Now, why is it like this? Now, let's look at the technicality. The consequent is always a larger class of denotations or members compared to the antecedent. So the consequent, you can look at both the antecedent and the consequent as classes containing items. And the size of the consequent class is larger than the size of the antecedent class. The consequent class contains more items compared to the antecedent class. So something could be in the consequent class, but it's not in the antecedent class. Meanwhile, everything in the antecedent class is in the consequent class automatically. The consequent contains the denotations of both the antecedent and possibly more. Now, the consequent Africans contains more members than the antecedent Ghanaians. When you deny something of membership in a smaller class, you have not denied it of membership in a larger class. But when you deny something of membership in a larger class, containing all the members of a smaller class, you have automatically denied it of membership of the smaller class. So if you can prove that Peter is not an African, you have automatically shown he's not a Ghanaian. So there are four ways. By showing that Peter is a Ghanaian, you have automatically shown he's an African. By showing that Peter is not a Ghanaian, you have not automatically shown he's not an African. Then the third one, by showing that Peter is an African, you have not automatically shown he's a Ghanaian, because he's an African, but he could be any other nationality in Africa. And then the fourth and the last one, by showing that Peter is not an African, you have automatically shown he's not a Ghanaian. Now let's look at, these are the four ways I've explained, the four routes an argument can take. Now they have names, and modus ponens, for instance. Let's look at the four kinds of deductive argument. Modus ponens. Modus ponens is an argument that affirms the antecedent. So any argument that affirms the antecedent is a modus ponens. All A's are B's. X is an A, therefore X is a B. So that's a modus ponens, and we are told it's a valid argument. Okay, all Ghanaians are Africans. Peter is a Ghanaian. Peter is an African. So that's valid. We call it a modus ponens. Now then, the fallacy of denying the antecedent. All A's are B's. X is not an A, therefore X is not a B. So this is an argument that denies the antecedent, and we are told it's not valid. We have also seen by ourselves that it's not valid. All Ghanaians are Africans. Peter is not a Ghanaian, which denies the antecedent. Therefore, Peter is not an African. So this is not a valid argument. Peter could possibly be a Cameroonian. Now let's look at the size of the antecedent and the consequent classes. Now these are two boxes. The consequent box is bigger than the antecedent box. Now you can see that everything in the antecedent is automatically in the consequent. The antecedent is squarely in the consequent. So everything in the antecedent is in the consequent automatically, but not everything in the consequent is in the antecedent. That's the difference. Not everything in the consequent is in the antecedent, but everything in the antecedent is in the consequent. That's why we have the rule for deductive reasoning. That's why affirming the antecedent will lead you to a valid conclusion about the consequent. But denying the antecedent will not lead you to a valid conclusion about the consequent. Or sorry, denying the antecedent will not lead you to a valid conclusion about the consequent. And then affirming the consequent will not lead you to a valid conclusion about the antecedent. But denying the consequent will lead you to a valid conclusion about the antecedent. Now, this is a box of Africans and a box of Ghanaians. The African box is bigger than the Ghanaian box. If you say Peter is a Ghanaian, automatically he's an African because Peter is in the African box. But if you say Peter is not a Ghanaian, you can't say he's not an African because there are other areas in the African box apart from the Ghanaian box. Then if you say Peter is an African, you can't automatically say he's a Ghanaian because the African box is larger. Peter could be an African in any part of the African box. So you can't just conclude he's a Ghanaian because he's an African. But if you deny that Peter is an African, if you say Peter is not an African, then automatically he's not a Ghanaian. You have denied him of being a Ghanaian, because if somebody is not an African, then he cannot be a Ghanaian, since the Ghanaian box is squarely in the African box. That's why we say that affirming the antecedent is a valid argument. Denying the antecedent is not a valid argument. Affirming the consequent is not a valid argument. But denying the consequent is a valid argument. Modus tollens. So modus tollens is an argument that denies the consequent. All A are B, X is not a B, therefore X is not an A. We are told this is a valid argument. Now, in words, all Ghanaians are Africans. All Ghanaians are Africans. Michael is not an African, therefore Michael is not a Ghanaian. So, if you can show that Michael is not an African, then automatically he's not a Ghanaian. So that's why I will say that denying the consequent will lead you to a valid conclusion. Now let's also look at the relationship between the department and the university. Now, all those studying in the Department of Physics are enrolled at the University of Ghana. All those studying in the Department of Physics are enrolled at the University of Ghana. Kevin is not enrolled at the University of Ghana, so Kevin is not studying in the Department of Physics. Now, just imagine that there is a debate about whether Kevin is in the Department of Physics or not. Some people are saying Kevin is in the Department of Physics. Some people are saying Kevin is not in the Department of Physics. To resolve the debate, we have to go and check if Kevin is enrolled in the Department of Physics. And then we go to the registry to find out if Kevin's name is in the registry. And then those at the registry search for Kevin's name in the university students database. And they are not able to find Kevin's name in the university students database. So if Kevin cannot be proven to be in University of Ghana, then there's no way he can be in physics. So if the registry or the registrar tells us that Kevin is actually not enrolled in the University of Ghana, then what does that do to the debate? It means the debate is dissolved because Kevin is not even enrolled in university. If Kevin is not enrolled in university, then there's no way he can be in the Department of Physics. So that's why we say that denying the consequent, denying Kevin membership of the University of Ghana, automatically denies him membership of Department of Physics. The Department of Physics is antecedent. University of Ghana is consequent. So denying him membership of University of Ghana automatically denies him membership of Department of Physics. So that's why we say that denying the consequent will always lead you to a valid conclusion. So that's the box of University of Ghana and the box of Department of Physics. If you can show that someone is in the Department of Physics, automatically he is in the University of Ghana. But if you show that someone is not in the Department of Physics, you have not automatically shown he's not in the department in the University of Ghana. Then if you show that someone is in the University of Ghana, you have not automatically shown he's in the Department of Physics. But if you show that someone is not in the University of Ghana, automatically you've shown that he's not in the Department of Physics. Now let's look at the fallacy of affirming a consequent. The fallacy of affirming a consequent. All A are B. X is a B, therefore X is an A. So this is an argument that affirms the consequent. And we are told it's an invalid argument. Now let's look at it in words. All Ghanaians are Africans. George is an African, therefore George is a Ghanaian. So why is the argument invalid? Because showing that George is an African is not enough to show he's a Ghanaian. If he's an African, he could be from anywhere in Africa. So that he's an African doesn't automatically mean he's a Ghanaian. And that's why we say that affirming the consequent will always lead you to an invalid argument. Or affirming the consequent will always lead you to an invalid conclusion. Or affirming the consequent is always an invalid argument. Now, the consequent Africans contains a logically larger category of denotations compared to the antecedent Ghanaians. So the fact that George is an African does not necessarily mean he's a Ghanaian. He may be a South African or a Cameroonian. If we affirm the consequent, we are not sure we can affirm the antecedent. In short, if we affirm the consequent, it will land us in the same kind of uncertainty that we saw in the fallacy of modus ponens, or the fallacy of denying the antecedent. Now let's look at another form of the fallacy of affirming the consequent. Now we've understood that affirming the consequent is invalid. Now, there's another form of affirming the consequent. It looks like denying the consequent, but it's not denying the consequent, it's affirming the consequent. Now, all A are not B. All A are not B. X is not a B, therefore X is an A. All A are not B. X is not a B. Now, these two premises are negatives. They are negatives. They are deniers. Now, negatives or deniers will always give you a positive or affirmation. Two negatives will give you a positive. Two deniers will give you an affirmation. So when you see this kind of argument where the premises are both deniers, you regard the argument itself as an affirmation, because one denial is affirming another denial. One denial is affirming another denial. So two negatives will give you a positive, or two denials will give you an affirmation. So you would say that this argument is an affirmation. Affirmation of what? It's an affirmation of the consequent. It's an affirmation of the consequent. So this argument is the fallacy of affirming the consequent. Let's look at it in words. All human beings are not goats. X is not a goat. Therefore, X is a human being. All human beings are not goats, which is true. X is not a goat. Okay. But is showing that X is not a goat enough to show that X is a human being? Does X not being a goat automatically mean that X is a human being? No. If X is not a goat, he could be anything apart from you. He could be a tiger, he could be a lion, he could be a giraffe or something. So again, not being a goat, which is a consequent, is a logically larger category than all human beings, which is antecedent. So the consequent is logically larger than the antecedent. So the fact that X is not a goat does not necessarily make X a human being. X could as well be a cat, a giraffe, or a tiger. Okay, so let's move on. Now, so that rounds up our analysis of modus ponens, modus tollens, and then their fallacies. So modus ponens is affirming the antecedent, and we've seen the fallacy of denying the antecedent. Modus tollens is denying the consequent, and we've seen the fallacy of affirming the consequent. Modus ponens and modus tollens are two valid types of deductive reasoning. Two types of valid deductive reasoning. And there are two other types of valid deductive reasoning. They are the hypothetical syllogism and the disjunctive syllogism. Sorry, give me a few minutes. Okay, so we have modus ponens and modus tollens. And then we have hypothetical syllogism and disjunctive syllogism. Now, hypothetical syllogism is an argument where the consequent of an initial or first premise becomes the antecedent of a second or subsequent premise. Now, so let's say all A are B. B is the consequent. And then B becomes the antecedent of the next premise. B becomes the antecedent of the next premise. That's why we say it's an argument where the consequent of an initial or first premise becomes the antecedent of a second or subsequent premise. And then subsequent premises feature the consequence of their predecessors as the antecedent. So it continues. You can have all A are B, all B are C, all C are D, all D are E. And that's why we say that subsequent premises feature the consequence of their predecessors as their antecedents. Then the conclusion brings together or pairs the very first antecedent with the very last consequent. So the conclusion will be, therefore, all A are Z. So if we have all A are B, all B are C, all C are E, and all the down to Z, the conclusion will be, therefore, all A are Z. The conclusion pairs or brings together the very first antecedent with the very last consequent. Example, all A are B, all B are C. So you can see that the consequent of the first premise, which is B, becomes the antecedent of the next premise. And the consequent of the second premise, C, can become the antecedent of another premise. So and that's why you can have all A are B, all B are C, all C are E, all C are D, and so on. And then the conclusion brings together or pairs the very first antecedent and the very last consequent. Therefore, all A are C. Or if the premises extend from A to Z, then the conclusion will be, therefore, all A are Z. So that's essentially the character of a hypothetical syllogism. Let's put it in words. All Ghanaians are Africans. All Ghanaians are Africans. All Africans are human beings. Therefore, all Ghanaians are human beings. So all A's are B's, all B's are C's, therefore all A's are C's. That's the way it goes. Now we notice that the consequent of the first premise, which is B, becomes the antecedent of the second premise. And the antecedent of the second premise, which is the consequent of the first premise, leads us to a new party, which is C, as a consequent. Any additional subsequent premise will typically feature the consequent of its predecessor as its antecedent, so that it's linked conditionally to a fresh party. Now let's look at two fallacies of hypothetical syllogism. So the hypothetical syllogism has two fallacies. The first fallacy, all A are B, all B are C, therefore all C are A. Now instead of saying all A are C, you say all C are A. So instead of saying all A are C, you say all C are A. So it's like exchanging the components. Now let's see why that is a fallacy by putting it in words. All Ghanaians are Africans. All Africans are human beings. Therefore, all human beings are Ghanaians. So you can see why it's a fallacy. Then the second hypothetical fallacy, all A are C. So instead of all A are B, you have all A are C. All B are C. Therefore, all A are B. All A are C, all B are C, therefore all A are B. Now let's put it in words. all Ghanaians are Africans, all Kenyans are Africans, therefore all Ghanaians are Kenyans. So that's why it's a fallacy. Now, sometimes it can be true by accident. For example, all Ghanaians are human beings. All Africans are human beings. Therefore, all Ghanaians are Africans. The fact that the conclusion of this particular argument is true doesn't mean the argument is correct. Now, this argument doesn't show you that all Ghanaians are Africans. If you knew that all Ghanaians are Africans, you knew that before this argument. But this argument by itself does not show you that all Ghanaians are Africans. So in spite of the fact that the conclusion is true in isolation, the argument itself is invalid. Of course, you can see that the argument cannot show you that all Ghanaians are Africans. So the conclusion is true by isolation and it's true by accident. So that's that about hypothetical syllogism. Now let's look at disjunctive syllogism. Disjunctive syllogism is a syllogism where the main premise is a disjunctive, an either-or statement. A disjunctive is an either-or statement. When we affirm something of any of the disjunctive items, then we have automatically denied it the other disjunctive part. For example, either A is true or B is true. Either A is true or B is true. A is true, so B is false. Or either A is true or B is true. B is true, so A is false. Now let's put it in words. Either I became a reverend father or I got married. I got married, so I did not become a reverend father. Or either I became a reverend father or I got married. I became a reverend father, so I did not get married. So that's a disjunctive argument. That's the fourth way of a valid deductive reasoning, or the fourth type of deductive reasoning. Now, a little exercise. Determine what kind of argument this is. What kind of argument is this? Anytime he goes to town, he passes by my mother's house. Anytime he goes to town, he passes by my mother's house. Today he passed by my mother's house, so he went to town. Anytime he goes to town, he passes by my mother's house. Today he passed by my mother's house, so he went to town. Is this a modus ponens or a modus tollens? Or is it a fallacy of denying the antecedent or a fallacy of affirming the consequent? Now, for your information, anytime he goes to town is the antecedent. He passes by my mother's house is the consequent. Anytime he goes to town is the antecedent. He passes by my mother's house is the consequent. So what kind of argument is it? If you want to answer, you can raise your hand and then unmute your microphone. Miriam, you can unmute your microphone.
So it is affirming the consequence.
It affirms the consequent. So that means it's an invalid argument. That means it's an invalid argument. Can you explain why it's an invalid argument? By looking at the argument itself.
He said anytime he goes to town, he passes by my mother's house. Today he passed by my mother's house, so he went to town. So him passing by your mother's house doesn't necessarily mean that the person has gone to town. Probably he has gone to the next house, but not to town.
Yeah, so that's correct. Yes. So it may be true that he passes by your house if he's going to town, because your house is on the way to town. But that does not mean that passing your house automatically he's in town. If he passes your house, he could be in the next house. So that's a common sense way of understanding why the argument is invalid. But the major way of finding out whether the argument is invalid is to ask yourself whether it affirms or denies the antecedent, or it affirms or denies the consequent. That is the technical way of knowing whether an argument is valid or invalid. When you have found out whether it's valid or invalid, the technical way, then you can ask yourself with your common sense. Then you can use your common sense to find out why it's valid or invalid. And you will always see why. Now, answer correctly. We deduce correctly when we deny the antecedent. True or false?
False.
False. That's correct. Number 2, we deduce correctly when we affirm the antecedent. True or false?
True.
Yeah,
True.
that's
True.
yes. Yes, it's true. Number 3, we deduce correctly when we deny the consequent. True or false?
True. True.
Yeah, that's true. And then number 4, we deduce correctly when we affirm the consequent. True or false?
False.
False. That's false. Yes, so that's correct. Now let's move on. Now we have understood the 4 types of valid deductive reasoning, which are the modus ponens, modus tollens, their fallacies, hypothetical syllogism and its fallacies, and the disjunctive syllogism. So those are the 4 types of valid deductive reasoning and their fallacies. Now, of course, we didn't see the fallacies of disjunctive reasoning. There will be no fallacies of disjunctive because the fallacy of disjunctive reasoning will be too obvious or too simple. You can't say you can't say either I got married or I became a reverend father. I got married, so I got married, or I became a reverend father, so I became a reverend. No, the fallacy is too simple, so we don't teach it. Now let's look at the issue of validity. The 4 types of deductive syllogism are 4 ways of making deductively valid arguments. A valid argument is an argument whose premises are logically consistent with each conclusion. The premises of a valid argument necessarily imply its conclusion in the manner that it's impossible to deny the inference without running into self-contradiction. An invalid argument is an argument whose premises do not logically imply the conclusion. In that case, the relationship between the premises and the conclusion is not that of logical necessity. You can proceed to deny the conclusion of an invalid argument without contradicting yourself. So when we are discussing inductive arguments next week, you will find out that the relationship between the premises and the conclusion is not a logical one. And you can affirm the premises and deny the conclusion without even contradicting yourself. So that's for next week. Now we are dealing with deductive arguments, which are completely accurate arguments. Either they are completely accurate or they are invalid. Now let's look at valid but not sound. An argument could be valid but not sound. Now, what is needed for validity? An argument is valid if it is either a modus ponens, a modus tollens, a hypothetical syllogism, or a disjunctive syllogism. Any of those conditions is sufficient for validity. But an argument could be valid but not sound. If an argument is not sound, it means that there is some falsehood in the argument, that a part of the argument is not true, which automatically makes the argument not sound. So an argument could be valid but not sound. Example, all human beings are immortal. Peter is a human being, therefore Peter is immortal. Now this argument is valid because it affirms the antecedent. It affirms the antecedent, so it's a valid argument. But it is not sound because one of the premises is not true. All human beings are immortal is not true. So the argument is not sound. So the argument is valid because it's a modus ponens, but it's not sound because there is falsehood in the argument. So we say the argument is valid but not sound. Let's look at other examples. All men are mammals. All mammals must get killed. Therefore, all men must get killed. If you look at this argument, you see that it's a hypothetical syllogism. All men are mammals. All mammals must get killed. All A are B. All B are C. Therefore, all A are C. So it's a hypothetical syllogism. That makes it a valid argument. But is the argument true? The argument is not true. Therefore, it's not sound. Because one of the premises is not true. All mammals must get killed is not true. So the argument is valid, but not sound. Now we can have invalid argument with true conclusion. An argument is invalid, but it has a true conclusion. In that case, you would say that the conclusion is true by accident. True by accident, just like we've seen before. Now, democracy is better than other forms of political organization because citizens in a democracy are holier than citizens in another form of political organization. Now, this statement is a complete argument. It's one of those arguments where the conclusion and the premises are in a single sentence. Now, the first part of the sentence is the conclusion. The premise, the supporting premise is the second part of the sentence. Democracy is better than other forms of political organization. That should be the conclusion. And then the second part is the premise, because citizens in the democracy are holier than citizens in another form of political organization. Now, do we accept the conclusion? Democracy is better than other forms of political organization. Of course, all of us will accept, most of us will accept it. It's generally accepted that democracy is better than other forms of political organization. But is that conclusion, do we accept that conclusion because of the reason given here? Because citizens in a democracy are holier than citizens in another form of political organization? No. We don't believe that citizens in a democracy are holier than citizens in another form. That's not why we think democracy is better. So you have a true conclusion, but you have an incorrect premise. Now the argument is invalid, but its conclusion is true. Now, true conclusion alone does not make an invalid argument correct. True conclusion alone does not make an invalid argument correct. Then we have valid and sound. To be sound, all the premises in a valid argument must be true. So all men are mortal. Peter is a man, therefore Peter is mortal. Now, this argument is valid because it's a modus ponens. It affirms the antecedent. It's also true because, oh sorry, it's also sound because all the arguments, all the statements are true. It is sound because all the statements are true. So the argument is valid and sound. So we have three forms. We have valid and sound, valid and unsound, invalid and unsound. Now we've already seen valid and unsound, but this is another example. Valid and sound. All snakes are reptiles, which is true. Cobra is a snake, which is true. Therefore, cobra is a reptile, which is true. So all the statements are true, and it's a modus ponens. So the argument is valid and sound. Valid because it affirms the antecedent, and true and sound because all the premises are true. Then you have valid but unsound. All snakes are reptiles, which is true. Mosquitoes are snakes, which is false. Therefore, mosquitoes are reptiles, that's false. So now this argument is valid because it affirms the antecedent, but it is not sound because one of the premises is not true. Then we can have both invalid and unsound, which is a double jeopardy. All snakes are reptiles, that's true. Mosquitoes are reptiles, that's false. Therefore, mosquitoes are snakes, that's false. Now, apart from the fact that mosquitoes are reptiles is false, it also affirms the consequent. It affirms the consequent. And affirming the consequent is an invalid argument. So the argument is invalid, and then there are falsehoods in the argument, so it is both invalid and unsound. Is an invalid but sound argument possible? No. An invalid argument is unsound, even if the premises and conclusion are all true. So if you see an argument where all the statements happen to be true from your experience, but the argument itself is technically invalid, then the argument is not sound, whether it is true or not. All Ghanaians are Africans, yes. Kofi is an African, yes, that's true. Therefore, Kofi is a Ghanaian, that's true. But the argument is invalid because it affirms the consequent. Kofi is an African, affirms the consequent. So it's an invalid argument. Then you ask yourself, with your common sense, why is this argument invalid? Because you cannot know that Kofi is a Ghanaian by simply knowing that he's an African. That Kofi is an African does not, authoritatively tell you he's a Ghanaian. So even if you know that Kofi is a Ghanaian, it is not from this argument that you got that knowledge. You got that knowledge before you saw this argument. And this argument itself cannot show you that Kofi is a Ghanaian. So the argument is invalid. And in spite of the fact that all the statements might be true, we would say it is unsound. Now, this is a technicality. Validity is needed for soundness. Validity is needed for soundness because soundness needs both validity and truth. But soundness is not needed for validity. So validity can do without soundness. Validity can stand on its own. Some arguments are valid but not true. On the other hand, soundness needs both validity and truth. Now, a little exercise. Identify the missing premise in each of the following deductive arguments. Now, these are deductive arguments with missing premises. All military men play football. Bob plays football. All military men play football. Bob plays football. What is the missing premise? So if you want to answer, you can raise your hand and unmute your microphone. All military men play football. Bob plays football. What is the missing premise?
Bob is a military man.
Bob is a military man. That's correct. So all military men play football. Bob is a military man, which affirms the antecedent. Therefore, Bob plays football. So that's a valid argument. And then all Americans are human beings. All Americans are mammals. What is the missing premise?
All human beings are mammals.
All human beings are mammals. Now, so let's arrange it. All human beings are mammals. All Americans are human beings. Therefore, all Americans are mammals. So all human beings are mammals is actually the false premise. Okay, so that's correct. Now let's go on. Answer correctly. Which fallacy is committed by the following? All A's are C's. All B's are C's. Therefore, all A's are B's. All A's are C's, all B's are C's, therefore all A's are B's. You can put it in words to find out what kind of argument is it, or what fallacy is committing. All Ghanaians are Africans, all Kenyans are Africans, therefore all Ghanaians are Kenyans. So it is this. It's the second hypothetical fallacy. Now describe the following arguments, or the following argument. All Europeans are not my friends. Ben is not a European, so Ben is my friend. Or you can simplify the first premise by saying no European is my friend. No European is my friend. Ben is not a European, so Ben is my friend. What kind of argument is it? Is it a modus ponens or modus tollens? Or does it deny the antecedent, or does it affirm the consequent? Now, you remember I said that whenever you see two negatives, then it's a positive. Two negatives will give you a positive. Now, premises 1 and 2 are negatives. So, combined, they give you a positive. So, if one negative is affirming another negative, then automatically it's a positive. So, you will say that it's actually an affirmation, not a denial. No European is my friend. Ben is not a European. That's an affirmation. And then the question is affirmation of what? It's an affirmation of the antecedent.
Antecedent.
Yes, it affirms the antecedent because European is antecedent. So it's an argument that affirms the antecedent. And that's a modus ponens. So whenever you see two negatives, you have a positive. Or whenever you see two deniers, then it's an affirmation. So that's the end of the class. So we'll be discussing inductive reasoning next class. Now I will take any questions you have right now before I begin to upload the recording. So if you have any questions, just ask it right away before I stop the recording, and then I leave the class so that I begin to upload the recording. Any questions? Okay, so now I'm proceeding to stop the recording.